Variable roll stiffness system of an automobile. Abstract in different road conditions. Everyone's first priority is comfort as well as safety, and there is a lot of importance of ride quality and ease while traveling. The comfort of vehicle is directly linked with the level of safety offered during various road conditions. Road safety is one of the primary concern of each and every automobile driver. The anti-roll bar is an established feature of suspension design and is found on just about every modern-day car, and plenty of classic cars too. In order to resist the car during the situation of extreme body roll, anti-roll bar works as a link which stiffen the suspension to control this sort of action. Our objective is to develop a new active safety system for vehicles which controls the overall vehicle behavior in emergency situations. An adjustable anti-roll bar having a single set of mounting apertures whose roll stiffness can be adjusted at the middle of the anti-roll bar, in which variable roll stiffness is achieved by providing gear mechanism consisting of 3 mitre-type bevel gears which is actuated by pneumatic means according to different road conditions. According to our design, we are working in the area of vehicle dynamics, in which our main focus is to provide variable roll stiffness at different road condition. Components which we will include for prototype building are 3 equal bevel gears, anti-roll bar, pneumatic piston plunger, suspensions. Pneumatic system is used which helps in providing flexibility to gear mechanism and hence improving the function of anti-roll bar. Keywords and component: road safety, anti-roll bar, coil springs, bevel gears, single acting cylinder, 3 halves direction control valve, pump, wheels, ECU, roll stiffness. I.Prelim definition. Anti-roll bar used in modern automobile cars serves the purpose of providing extra roll stiffness during the condition of excessive cornering and makes the car less prone to extreme body roll. But while driving on highway, above-mentioned function of anti-roll bar will result in improper ride with tire frequently losing contact with the road surface. According to the data provided by Indian government in a year of 2017 form, total number of accidents 3,27,448 are due to overspeeding of vehicle 1. Why vehicle stability is required? There are many reasons for a vehicle to lose its controllability: unfavorable weather and road conditions, lack of regular vehicle care, maintenance, and repair, the driver's inexperience, sharp cornering, when passing an obstacle or underestimating a curve. A vehicle will react in a different way when the driver steers smoothly, or when the vehicle slightly declines from the lane. Loss of stability of a vehicle may cause it skidding on the road. In above-mentioned conditions, for the safety and comfort of an automobile as well as driver, stability is the major concern which needs to be considered. 2. Introduction. Variable roll stiffness system of an automobile is a system which provides varying roll stiffness, adequate stability as well as prevents the rolling of vehicle while excessive turning. By observing the current road scenario, it becomes mandatory to understand vehicle behavior in accordance with respective road conditions. Imperative condition to correlate the vehicle behavior with different road condition is that vehicle stiffness must vary as per various road condition. Successful implementation of this system will decreases the chances of vehicle getting rolled over. This system includes anti-roll bar, pneumatic system, coil spring, electronic control unit, bevel gears, suspensions and wheel. Anti-roll bar is connected to the suspension strut. Anti-roll bar and suspension strut are interconnected through a ball-jointed link. Combination of 3 mitre-type bevel gear mechanism is placed in centered section of anti-roll bar, which provides opposite rotational motion relatively. We have double-acting cylinder with 3 halves DCV which controls engage and disengage of gear mechanism. Shape of anti-roll bars for automobile suspension systems are usually designed from a standpoint of avoiding physical interference with other components mounted on the bottom of a vehicle. Also, the diameter of the bar is usually pre-selected and fixed to achieve a desired anti-roll stiffness. After having this much amount of constraints in shape and dimensions, there is little design flexibility for engineers/designers. So in present invention we have configured the mechanism consisting of 3 mitre-type bevel gears which can be engaged and disengaged. In engaged position of gears, anti-roll bar will provide continuous traction while cornering. In disengaged position of gears, it will flourish the riding comfort during uneven road conditions. The name of the system itself implies that it can deliver some excess amount of roll stiffness to vehicle. The arrangement of components and working efficiency of gear mechanism is maintained in a way that stiffness can be fluctuated according to various road conditions. For instance, while driving on a highway, in order to take sharp turns as well as to achieve traction with road surface, roll stiffness should be conserved at high rate, but for off-road conditions where stiffness is not one of the concern, then only disengagement of just one member from the mechanism will provide smoother ride. After compilation of each and every component in a single unit, all of them are working in the system with our desired efficiency. This efficiency is achieved because of well-designed system, correct arithmetical calculation of each and every forces as well as dimensions, load analysis resulted by observing each and every possible load conditions. In addition to all of these, appropriate material selection and carefully manufactured parts are also the reason behind successful implementation of the system. There are some evaluated decisions which are taken on the basis of critical observation at each and every loose ends. Initially we have selected hydraulic system for the actuation of bevel gear mechanism, but after following the market closely we have evaluated that pneumatic systems are more cheaper and quick in response, so we have selected pneumatic system to make bevel gear mechanism work. After learning from various reference books we understood that means for compression of suspension at either side and having expansions on the other side, bevel gears are perfect choice. For ease of calculation and mounting feasibility, mitre type bevel gears are best in use. In order to achieve the aim of variable roll stiffness we can also work in the area of suspensions, but suspensions are one of the most critical part of the vehicle assembly, so according to constraint of cost effectiveness and ease of designing we have selected the anti-roll bar as a main component of the system. Basically we have implemented the technique of reverse engineering to achieve what we have thought. Conclusion. By using different material with different dimensions we can design and manufacture such a system which can attach with any current automobile. The final system as per our knowledge, research, study, and discussion is that according to the current situations, the product should not be costly for its function and also that is a small and compact unit. Its endurance limit should be high and the design should be such that in future additional options, redesigning, additional features can be incorporated in the current design, and this product should excel in its functions as cost, working, maintenance and feasibility.